Hello everyone. Today I want to talk about density altitude and why density altitude is important and why we need to calculate density altitude for each flight. Basically, density altitude is pressure altitude adjusted or corrected by non-standard temperature. So let's do one example. You are at the sea level and temperature is equal 15 degrees and altimeter setting is 29902. What's the density altitude? So first of all, for density altitude we need to calculate pressure altitude. So pressure altitude, it has its formula 29902, standard atmospheric pressure minus current altimeter setting multiply 1000 plus elevation. So, and this station, first of all, we can calculate pressure altitude 29902, current altimeter setting minus 29902, multiply 1000 feet plus elevation. You are at the sea level, elevation is equal 0 plus 0. So, that's pressure altitude equals 0. For we multiply 1000 feet because for each 1000 feet pressure will decrease 1 inch of mercury. So at this station, pressure altitude equals 0 and temperature is equal 15. So for calculate density altitude, we need to E6B. So by put the pressure altitude opposite of temperature. So if you see at this window, we set the pressure altitude 1000 of feet. Pressure altitude equals 0 and is 0, and opposite side temperature is 15. So 15 degrees opposite side of 0 pressure altitude. So we can read density altitude in this window is equal almost 0. So density altitude at this station 0. We can see when you are at the sea level and when we are in standard atmospheric pressure, because 299 is standard atmospheric pressure, and when temperature is equal 15 degrees, density altitude equal pressure altitude. So let's talk about when you are at is higher altitude. So you are flying at 3000 feet above sea level, for example, and altimeter is equal 29900 and temperature at 3000 feet equal, for example, 10 degrees Celsius. What's the density altitude? So as we said, first of all we need to calculate pressure altitude. Pressure altitude, standard atmospheric pressure minus current altimeter setting that you did already, 29900 multiply 1000 feet plus elevation or height above sea level. You fly at 3000 feet, right? So by calculator 29902 minus 29900 multiply 1000 plus elevation or height above sea level equal 3920 feet. So pressure altitude 3920 feet. How about temperature? First of all, we need to calculate temperature. As we know, at the sea level temperature is standard is 15 degrees. So at 3000 feet, as we know, for each 1000 feet Due to a standard lapse rate, temperature will decrease in 1.98 degrees centigrade, and when the round is 2 degrees centigrade, for each 1000 feet, temperature will decrease in 2 degrees. So at 3000 feet, multiply 2 degrees equals 6 degrees. So a standard temperature when we are at this 3000 feet should be 6 degrees, right? But current temperature at 3000 feet at 3000 feet is 6 degrees decreasing from a standard temperature. 15 degrees minus 6 degrees equal 9 degrees. So a standard temperature at standard day at 3000 feet should be 9 degrees, right? But at this scenario, temperature is 10 degrees. That means we are at warmer than standard temperature, because 10 degrees in compare 9 degrees, 1 degree is higher than 9 degrees. Why that? At this situation we are at warmer than standard temperature. So we calculate pressure altitude 3900 feet and temperature is equal 10 degrees centigrade. By calculate and put in the E6B 3920 in window, and temperature is 10. Somewhere here you can see it's 10 degrees centigrade and 3920, like this. You can read density altitude at this window around 4000. So density altitude at this station equal almost 4000 feet. So we can see 4000 feet density altitude in comparison pressure altitude is higher. So when we are in warmer than standard temperature, usually density altitude is higher than pressure altitude. So let's talk about why density altitude is changing different altitude and different temperature. Density altitude is dependent on a couple of factors. So first, temperature. As the temperature increasing, density altitude increasing. As the temperature decreasing, density altitude decreasing. Another factor is compacting density altitude is pressure. So in low pressure, when in higher altitude, due to the air is less dense, right? Density altitude increasing. And with high pressure, or lower altitude, due to the air density high, high pressure, the air density is higher, density altitude decreasing. Another factor is impacting density altitude is humidity. So, when humidity increasing, density altitude increasing. This three factor is main factor that impact to density altitude. So, regarding to these factor, when in higher altitude, or other means when altitude increasing, due to the air is less dense, density altitude increasing. So we have a higher air density altitude in higher altitude, and in lower altitude, due to the air density increasing, density altitude decreasing. Another factor is very important is humidity. When humidity is high and also when temperature is high, density altitude increasing. So these factors impact to aircraft performance. So what's that mean? Let's talk about aircraft performance regarding to density altitude. We are assuming density altitude increasing. So what conditions should we have to density altitude increasing? When temperature is high, humidity high, or we are in higher altitude, density altitude increasing. So when density altitude increasing, aircraft performance decreasing. We are assuming you are at a runway and temperature is equal to 20 degrees centigrade. It doesn't matter you are at the ground at sea level or elevation equal is 1000 feet. It doesn't matter. But due to the temperature is warmer, aircraft performance decreasing. So aircraft performance decreasing can impact to takeoff distance. Number one, because due to the density altitude increasing, air density decreasing, and the air is less dense. Why that? We need to much more distance for off the runway and enter the airborne. Another impact can be for landing distance. When you are in higher density altitude, due to the air density is less, usually true airspeed is higher. Why? Because indicated airspeed supplied by pitot system, and in situation is density altitude increasing, that means we are in lower pressure. So pitot system has lower pressure And why that is true airspeed higher than indicator airspeed? Why that is we need to add 2% for each 1000 feet altitude, add to indicator airspeed. For example, if you are at 4000 feet and indicator airspeed is equal 100 knots, airspeed for each 1000 feet should be at 2% to indicator airspeed. At 4000 feet, 8% equal 8 knots. So at 4000 feet, true airspeed is equal 108. So, and when you are in higher density altitude, when temperature is higher, is impact to landing distance because true airspeed is higher and we need to much more distance for stop at the runway. Another factor that impacting aircraft performance, rate of climb. Because in higher density altitude, due to the air is less dense, engine power decreasing. Why that is rate of climb decreasing in higher density altitude. And also another impact is propeller. In higher density altitude, propeller produce less thrust due to the air density lower. This factor is main factor that impact to density altitude when we are in higher density altitude. For lower density altitude, all this explanation we can do opposite. So why that we need to calculate density altitude for each flight, especially when you want to go to the cross country, because in cross country you fly in different area and different pressure, and you need to know about exactly amount of the density altitude, because aircraft feel how flying in regarding to temperature and density altitude. Thanks for watching.